All right, so let's get this thing started. All right, so I wanted to thank Mike for inviting me. I know it's funny, Mike emailed me one time and said, can you please come and talk at the user group so I can prove that I know you? Because I've known Mike for a while I did a little bit of mentoring work with him, and he's been to my conference that I used to do, True North PHP. I used to help run for 5 years. I'm doing another conference, but I'm going to save the pitch for that after the end. So thanks so much for taking personal time. I know for me personally, making time to come to these things, I've moved a bazillion miles away from where I used to live. I used to live in Milton, which, as we know, is the far edges of the Greater Toronto area. And I actually helped get the Greater Toronto Area PHP user group up and running, but in my personal life, it became way too hard to get my kids squared away, my wife home from work, and all that stuff for me to hop in my car and go all the way into downtown Toronto. So I stopped going to the meetings of the group I helped found. So, I mean, these things happen. And so now I'm all the way out in the tiny village of Lucan, Ontario, which is about 2,500 people, and it's about 20 to 25 minutes north of London. So there's a user group there. I've been busy all the times that they ran their meetings, so maybe I'll go to the October one if I'm in town. So this little talk is called Lessons Learned from 10 years of testing. There's other ones. It's been more than 10 years, but I wanted to share some things that I've learned over being a testing evangelist, because it's for the longest time was like a really tough position to be in because nobody gave a shit about testing. And so I've seen things change over time, but I know there's a whole bunch of trends, so I wanted to share some of these things. Because the too long didn't read things, that tests are made of people. This is the thing that people don't understand, that I've started wanting to teach people about. Because it's really, tests are, I mean, they're code and their approaches and their frameworks and all this stuff, but they're really about people, and I'm going to explain why. This is fortunate because we have someone here who's not a PHP person. So this talk contains no code or tests. It's all about theory, so sorry, not sorry. So we start off in December 2002. I'm about 10 months working at this place that was all about building a adult dating site for sleazy businessmen to cheat on their wives while they're on the road. So it's December 2002, humongous crunch time. It was a very stereotypical PHP MySQL application of the time. So you got to remember, this is before any actual web application frameworks even existed. So everybody had just jammed everything together. So we had our presentation logic mixed in with our database stuff, mixed in with decision about what page. And of course, there were 0 tests. So it was a small team that built this thing out. And it was poorly constructed because nobody really knew what they were doing, because nobody who was working there never built one of these things before. It's like, how hard could it be? And of course it was really fucking hard. But we're building this thing out, and I was making tons of mistakes, and the team was making tons of mistakes because we just didn't know any better. And I ended up working 120 hours of overtime in 6 weeks leading up to Christmas. Literally, everyone stayed there like another 4 hours after their shift, just in case we were needed. The managers were nervous or control freaks or whatever. I don't even care after all this time. It was just all nonsense. And we had to sit around, and I got a lot of free dinners and a lot of angry phone calls from my wife. So, and despite what you think, they didn't balance out. So this was clearly a recipe for burnout, right? I had a super long commute. So I was living in Milton, and I was taking the commuter train GO train. So it used to take me 90 minutes to get to work and 2 hours to get home because of train connections and stuff. So I was losing out on, a whole bunch of time. And it was making me really unhappy. So just the commute was stupid. I'm on the train, and I had no control over the schedule and no control over where the trains went. So it kind of sucked. It was nice. I got on at the last stop, always had a seat. But on the way back, it was terrible, right? And weather delays and all this stuff, and many times. And then because of this overtime thing, I always had to beg for rides from people that I knew to at least take me up to one of the stations where I could catch a bus, because I used to have to take the bus because the trains for Milton were rush hour trains only. So if I didn't get out of the office at like 6 o'clock at the latest, there was no way I was going to catch a train home. So that was making me mad. And so I had this mandatory overtime nonsense. So of course we launched, and it was a humongous crash. right? So many assumptions about what we were doing was wrong. The architecture was wrong. The dickhead sysadmins that we work with lied to us about how MySQL replication worked and how long it would take. We built, at that time was very typical, an N-tier application. So a bunch of web application servers at the front, and then a couple like management machines, and then a whole shitload of database slaves and a master. The site was just so poorly designed. We had some of the slaves were 30 minutes behind on replicating writes to it. Can you imagine today an app that's like you do something takes 30 minutes? Like people get upset when it takes like 30 milliseconds for a website to respond to them. So all these assumptions. So it was just a terrible, terrible thing. I bribed my wife with a really nice Christmas gift from all the overtime money. But I said to myself, never again. I don't care what it takes. I'm never, ever, I don't care how many places I quit, how long I don't work. I'm never going to go through this again. Because working at this place and doing that sort of death march showed me like everything wrong with software development in the early 2000s, right? So this is 2000, yeah, this is 2002, December 2002, January 2003, when all this stuff started happening. It's like, and I see some of that stupid shit replicated today, so it's nice to see that it's still going in this stupid cycle. So afterwards, when we're doing the postmortem, we're talking to our project manager, who was a really great guy. I still talk to him on Facebook, so it was, not total loss of having worked there. And he said, when we were in there in the meeting afterwards, and they fired the guy who was the team lead of all the developers because they needed a scapegoat for the thing not having gone well. And so I'm in the thing, and I'm talking to the guy, and the project manager, Todd, was like, well, I'm not going to need this thing. And, like, he opened up a drawer, and they had, like, a whole package ready in case I decided to, like, freak out and yell at them that they were going to fire me, too. So basically, okay, we're not going to need this. And he threw it in the garbage. So I was like, okay, so at least I can stick around here. He said, but I think you should read this book. So this was Extreme Programming Installed by Ron Jeffries, Ann Anderson, Chet Hendrickson. And he said, I really think you should read this book. So take this book home over the weekend. Let me know what you think. So this was the moment that changed everything for me, like in my programming career. I'm not even remotely kidding. I'm not being hyperbolic. Because the thing I discovered about this was there was a whole chapter on unit testing. And unit was the thing that they came up with out of the Java world, where Kent Beck and a couple other people said, okay, let's wrap our minds around this idea of let's do some tests. And these tests are all going to be based around scenarios that contain assertions where we're going to write code to test our other code to make sure that our assumptions are correct. So they're all assertions. And I was like that thing about the light bulb, like whoop, over there. It's like, oh my God, you mean there was like there was a way that we could have stopped this super horrible launch from happening? Like instead of letting our users debug the site for us, we could have done this for ourselves. It was like an epiphany, and never mind all the other extreme programming stuff, which was about extreme programming, pair programming, which is something I enjoy doing. Don't get to do very much of anymore. But just like the whole agile thing and estimating and stories and all the stuff that's Scrum and all that stuff. This is where a lot of these ideas came from. So of course, since that book was written, I don't know, 2000. Even 1998 or 1999. So a common theme I found was a lot of these things that people have figured these things out before, and we were just too fucking stupid to see or ignorant to really figure it out. So this is what even came. Like this is reading this book, and I don't think Todd, the guy who showed me this book, even knows because I've told him a few times. He just dismissed it as a developer just being excited about something new. It's like no, Todd, you have no idea. So here's the problem, right? There were testing tools for other programming languages, Java, of course, being the big one. So there was almost nothing on the PHP side. So what did we use when we decided? I got this thing, and I said, oh my God, this unit testing thing is good. And I talked to the project manager, and the project manager talked to the person who was in charge of the developers now. And I'm like, yeah, this testing thing sounds like something that could be good. So let's go through this. We're going to go through the Apache logs, and we're gonna get someone to write some sed awk grep thing and figure out what's the most common errors, and then we're going to write tests and eliminate all these errors as we go. So this is even before PHP Unit had a stable release. I didn't even know PHP Unit existed back then. If it did, I don't know. I could always go ask Sebastian when was the first version made available. But we used this thing called Simple Test, which was a web-based unit testing tool. You write your test, load the web page, everything passes green or red. And this was just like, boom! to other developers too, seeing this thing. Like, wow, can't believe that there's this thing that actually lets us do this. So simple tests and lots of swearing as we tried to figure out how to write tests. And of course, finding all that stuff out too, that we had to like refactor our code to make testing easier. So that caused a lot of friction. And the thing too is that there was so little PHP-specific testing info available at that time. I joke about I had to do the testing both hills up ways in the snow. And okay, that's like, tiny bit of an exaggeration, but nobody was doing what I was doing. I couldn't even find anybody else who even had an inkling of like, well, what are you trying to do? What is this thing? I have no idea. Why would you want to do that? That sounds like a ridiculous waste of time. So it caused lots of personal sadness and then sadness within the company as the mandate came down. No, Chris found this thing. This has value. We're going to keep doing it, right? So the lesson number one that I learned was that this thing, right? Having one person enthusiastic about writing tests, it's not enough. It simply isn't enough. If you're in a situation with a group of developers and you are the only person that cares about testing, it might not end up good. Because much as we have cowboy coders, just go and randomly do a bunch of shit and push stuff into production, and boom, it works. And at some places, the cowboy code mentality is encouraged because it gets results or fits some stereotype that people have about programmers. So there's cowboy testing, which is where you're the only person doing it. Now, you can start off being the only one writing the tests, and I've certainly done that at a number of places over my career. But company culture might make you regret it. Some places might not be cool with it, especially I find in situations if you're doing agency work, right? Or you're doing work for somebody else. You're doing an agency, so you're creating an application, or even as a freelancer. You're doing this work and then you're handing it off to the client, and hopefully the client is happy with it, right? It's really tough because oftentimes you'll get like, we're wasting time, we don't have time to write tests, I'm not paying you to write tests, all these constant litany of excuses that I have that are so easy to refute these days because there are way more people like me around now. But company culture was always the issue. If you wanted to write tests, you were literally looking for a unicorn as an employer at that time. So tests will continue until no bugs are found. Of course, we know it's nonsense because testing doesn't guarantee there's no bugs. It just means you can usually find bugs that you know about. And then you're left with like really weird edge cases for things, right? So as much complaining from developers, through the tests and blah, 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 and this is so stupid. And why did Chris suggest it? And why does that guy fucking Kerry always sneaks out early to grab the Go train, blah, 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 blah. All the usual cultural nonsense that goes on. And still to this day, even now, X number of years later, still tons of complaining about having to write tests. So what happened when I was there, right? So tests got written. I started getting more interested in the process, and then I lost a political struggle to get the job I wanted at that place. Where they did a reorg, and there was this really cool job, and I was going to get this, and then the person who didn't like tests got the job. And I was like, fuck this, flip the table, I'm out, right? So I lost a little struggle. So that's where I also learned about politics in the workplace, and they definitely apply to when you're trying to. They definitely apply when you're trying to get new practices put in place. And testing is a humongous change for most people. So I left that place like December 2005. I got a job working for a company that owned a huge number of forum sites using this commercially available PHP forum software called vBulletin. I don't know if anyone's ever heard of that. They own like 200 of them. Why they hired me, I have no idea. They're like, well, we can just hire this guy and get him to do some work for us. So I tried to do some stuff for them, and they had no clue what they wanted, and vBulletin was proprietary, and we couldn't touch anything. So I got into doing open source stuff. The guy who owned the company said, hey, I want to find a way to get some stats out of Google Analytics. So this is like 2006, right? So all those tools weren't that nice. So I found some code that would let me pull in all this information from Google Analytics and then do some nice graphs and stuff. And it was written in Cake, PHP framework. So super long time ago. So when I got into Cake, and so contributing open source, so like I said, that's where I got involved with open source software. And they had tests for their stuff. So I learned about testing, and I learned about how to be a difficult person on a mailing list, because I chose to troll back in those days, rather than be the helpful person I am now. And also learned how to deal with difficult people, because I was a difficult person and was trying to figure out ways to manipulate people into doing the stuff that I wanted to do. So Cake was a good thing. And the lesson I learned out of Cake was that if you have a project that has tests, it usually means that somebody at some point used to care about what was going on. There's plenty of projects that start off with lots of tests and then nothing happens. Again, it's a cultural thing. Open source projects tend to take the characteristics of their leaders, right? All their good habits and often a lot of their bad habits too, right? So if the people who are at the top, so to say, leadership or whatever you want to call it for a piece of software, if they're driving the thing for tests, people do tests. People, let's be honest, most people are like sheep and they're just going to follow what the people around them tend to do. Real mavericks are like really super rare. I'm not as mavericky as people might think. I tend to go along with stuff if I agree with it. I complain loudly if it's not, but if there's something good, I'll go along. Or if we're working together towards a goal, okay, I'll suppress all the grumpiness and go along with stuff for a bit. But the test, any project with a test means that somebody cares. And then you just need to find those people that care. And then the tests keep going. Because there's nothing worse than like a bunch of tests and then people stop writing them. Because then you might as well just delete the test suite. If no one's going to use them, no one's going to extend it, might as well get rid of them, right? Again, people. So it has nothing to do with how you run those tests or how do you write the tests or how do you add tests. It's a people thing. If the people at the top don't believe in them, nothing's going to happen. So why are tests such a good thing? Well, tests provide windows into bugs, right? I tell people if they're asking me, I don't have any tests for my application, where do you suggest I start? I always tell them, well, a good way to start is any future bug fixes need a test that proves the bug has been fixed. So if you follow that sort of mentality, which happens all the time on legacy apps, because there are very few applications, greenfield ones, meaning starting from scratch, where you have a test suite alongside. It's super rare. At Mozilla, where I work, lucky enough that a bunch of the projects, one of the projects I work on, they've got tests right from the beginning. So they're at 100% code coverage, so I always have confidence that when they push stuff, I'm not going to have to worry too much, right? But again, we have to understand that tests are still written by people, and people are willing to argue about everything and anything. In fact, a lot of people revert to like kind of like a toddler state where they're more concerned about like being in charge of the process and getting their way, and then forgetting like why it is they wanted this thing. Like I have a friend who has a toddler, and I was just visiting him over the weekend. It's like, yeah, I could see the kid mulling through. How do I manipulate everybody around me to get this thing that I want? And then the instant they got the thing that they want, they moved on to something else. So people want to argue about everything. So I think if you look at, from a people perspective, tests that are driven by bug fixes, they help you find all the weird decisions you made, but don't remember why in your code. It's the idea I don't know if people have heard of this idea of like the +1 or -1 thing of debugging. Sometimes you have some code like, well, we just add 1 to this value, or if we just pop one element off the top of the array, the code works the way that we're supposed to. People do those sort of things rather than like actually get in at a lower level and understand, well, the code was written incorrectly, so we should fix the code, but it's a much easier thing to just go, well, I'll do this one line and we get on, right? So over time, when you look at these tests, you can look at the test and go, oh, so this is how this thing works, and this is this weird edge condition. Yeah, we hadn't bothered checking to make sure what happens if you try to send us, 3,000 characters instead of the 10 characters it's supposed to get, SQL injection and all that other wonderful stuff, right? Again, a people thing, right? We're seeing the mistakes that we made and hopefully why we made them and then how we decide to fix them, right? But more importantly, they also show you how to actually use the code. This is the kind of a superpower of having your tests, is that if you're on if you bring a new programmer onto your project, regardless of skill level, if you have like a really good tester, you can say, hey, you want to know how we need you to alter. Here's a ticket. Go implement this thing or go fix this bug. They can look at the code and look at the test and understand how that particular module of code works, which is huge because so few projects are documented in a way that's friendly to people who need to come in from outside and use it. Because we all have our own biases and we subconsciously avoid parts of the application that are weird or tricky, or we don't remember why is this a for each? Why are we breaking it? Why is this condition here to break us out early? And just why do we architect this thing this way? Why is always the question. Why is it this way? They'll show you. Your tests can show you. So it's like having another team member saying, hey, remember when we fixed this bug? Here's what we had to do. So I think you can think of the tests. You can often sell them as stealth documentation for your application. The tests are written by people, and bad tests happen. So this is a thing that we face all the time if we're not given a chance to do test-driven development, if we're going to a legacy code base, we go back and write the tests. Test-driven development is not just about testing, but it's a design technique. You're using it to guide how you're going to build your code, your APIs, your class definitions, your interfaces, how you want everything to work. So you code much differently when you're doing TDD than you do if you're going to write tests after the fact. Because when you're doing TDD, you have everything in front of you. You're creating an idealized version of how you want this system to work. When you have existing code, your tests are totally different because you're trying to go back and like justify what you've done. I write tests that cover this thing and this thing and this thing. And so you're not really thinking the same way. When on the occasions I get to do TDD, I'm coding very, very defensively, right? Early returns, filtering lots of stuff, just making sure to like, I have, my acceptable paths. I'm like, I want to make sure that nobody can bust the code and do things in a way that I do not want, that they can't use the code in a way I don't want them to use it. When it's legacy stuff and you're going back and writing tests, well, you're already a little bit biased and almost poisoned by the experience away because you're like, well, I know how it's supposed to work already, so I write the test assuming based on the way that I know it works, rather than writing tests. Because I very rarely see someone for a bit of legacy code when they go and like, okay, I need to write a test for this function that's in this method that's in this class. Very rarely will I see someone write a test with the goal of breaking it. Very rarely will I hear them say, well, what happens if I pass it a string when it's expecting an integer? Especially, if it's older code and you're not using it for PHP folks, if you're not using type hints and things like that. It's like, well, why aren't you writing a test to verify that this thing is behaving, that this thing will reject stuff if you pass it the wrong thing? People always choose the happy path. What's, the happy path for a test when they're going after? I'm just going to write tests that assume everything is good, rather than like, what happens if we have something really, really weird happen, right? Those are bad tests. If you're only ever testing the good things, then you are going to get bitten by something like really super weird. And again, like defensive coding style goes hand in hand with tests. You want to make sure that people are only using your code in the ways that you approve of. And all other like weird ways that people attempt to do it, you need to find a way to write your code to prevent them from doing that. Early returns, filtering, validation, all that stuff is all about making sure nobody's using your code in a way that you don't expect. So they're bad tests all the time. You have tests that do nothing. I've seen people write tests where they're using doubles all the time, which people call mocks, being pedantic. A mock is just a type of test double. It's like the whole Masons versus Shriners. When I say that, people get that reference, right? Every Shriner is a Mason, but not every Mason can become a Shriner. It's like, I don't know any other way to explain it. You use doubles. They're called test doubles. A mock is just a type of double. But because Sebastian called it Get Mock Builder, everyone calls them mocks, right? So the thing about with people writing bad tests, critics of the whole testing thing, they use it as evidence that tests don't work because they'll be like, well, our people wrote all these tests and we're so concerned about test coverage and, our test coverage is whatever percentage, and yet there's still bugs. So, Mr. Smart Guy, why are we even bothering about tests, right? But it's like, this is like no longer an undecided thing, right? There was a study a number of years ago done where they took a whole bunch of people and they all gave them the same thing to do. And they said, okay, we want some of you to use test-driven development and some of you to do whatever. Some do test after, some do, don't bother writing any tests at all. Just do what you would normally do without tests. So the thing that they found was that the group of people who did test-driven development, it took them 15 to 30% longer to accomplish the task, which makes sense because tests are code. So we are writing additional code, and there's additional process and additional time. We write the test, we run the test, we verify everything works okay, we commit that test into our version control system, and then we go on to the next task, right? Clearly, tests take more time. You're not saving any actual coding time by doing tests. But what they found was that the people who did that stuff, they had 40 to 90% fewer bugs make it into production, which is crazy. Like, if you like to manipulate stats the way that I do, you just like tell somebody who's like not entirely convinced about the testing thing, look, man, for one extra day a week, we can have 90% fewer bugs, which of course is like, just a little bit fudging it, a little bit of a white lie, right? But it does not change the fact that it's finally empirical proof. This study was done like in 2008, and every study that has followed it afterwards has been able to basically replicate and confirm the same thing. Yes, you are. What you are actually doing is that you are moving the time that you're spending fixing bugs from the most expensive part of the development life cycle, which is when it's in production, to the cheapest part, which is your developer time, right? Because let's talk about this, right? Let's say your developer is costing you X, right? It's X amount, right? So a person does something, developer does the work, that's X. So if they are lucky enough to have, like, say, some type of peer review system in place, so if a bug makes it out of the developer's environment because they're not doing tests found by a peer, okay, so now that's 2X it cost, right? Because it has to go back to the developer, make the fix, go back to the reviewer. Reviewer says, great. And then if you're really lucky, you have a QA environment. QA person goes, oh no, man, this thing isn't, here's the spec, and I ran through all these things, and this doesn't work. So you're like, oh, crap. So you go back, again, so now we're maybe at like 4X, right? Because now you've gone back and you fixed it, and the peer has to review it, and then your QA person has to say thumbs up. And then if you go into production, well, all bets are off. How much it might have cost you to let this bug go into production. Some are like really trivial, like a style sheet is off, or you forgot to run your code through a linter before you pushed it up or whatever. But there's some bugs that are catastrophic. You could bring your business down. You could delete your database. You could expose credentials to your website. You could allow, you could leave a login and password for yourself that's admin, and someone gets in and looks at everything. I mean, these things happen all the time. If you think what happened to Equifax is like an isolated thing, no, Equifax just got busted because they were really stupid and their executives sold a bunch of stock before they announced the leak. Otherwise, it would be just yet another leak, because there's no penalty these days for having poor security. No one even gets sued, and corporations, especially in the US, can insulate themselves from these things. But like, imagine you find a bug that's in production that's a showstopper. I almost guarantee you, if you had a culture that says we write tests for every bit of code, every line of code that we write, the chance of that bug actually making it into production has to, just because of the way testing works, has to be really, really low, 40 to 90% lower, I would imagine. I've seen enough catastrophic bugs. When I was working on that adult dating website, they also did a lot of porn on the side, so they made me write a little porn viewer thing for them, and I didn't write it the right way, and it brought all the servers that this thing was hosting the images on to a crawl, because I wasn't like caching things. I did a whole bunch of other stupid shit. So I kind of learned, right? Oh yeah, maybe you should test your stuff on an environment that's as much like production as you can. But see, people use all these excuses about bad tests, and we still get bugs as a reason to not do it. But no. This is a solved thing. This is like, there's proof. I can point to people and say, look, just go fucking read this thing. And then tell me again, look me in the eye. Maybe if they're really short, they can't. But look me in the eye and say, no, man, we're not going to do any tests, right? But I'm saying, when you get people that say, I don't believe in tests, they slow us down, we're agile, it's like, yeah, don't work with people like that, ever. I'm telling you right now, it is a waste of your time and your skill to work with people that don't believe in the value of tests. Because what's inevitably going to happen is something catastrophic is going to happen because they chose to cut some corners. Because people who generally say stuff like, we don't believe in tests, well, they're probably not going to believe in a lot of other things, like we don't believe that our developers should go home on time, or we don't believe in bonuses, or we don't believe in letting people have access to new hardware. We don't believe in paying people for IDEs and all this other stuff. And I'm sure everyone here has had enough of those experiences in environments like that, right? Don't work with people that don't believe in tests, ever. It is a waste of your time. We are in an in-demand, highly paid profession. You may not believe it, but there are still tons of jobs out there. Even if you are geographically limited, there are still plenty of things that you can do that are better than working for dipshits that don't want to test. So after all this stuff, and I spent some time in the wilderness, I worked for that place, and I did some stuff for CakePHP, did a couple contributions, and my code is still buried somewhere inside the framework with a little note that I contributed. So I spent a bunch of time, and then I started going to conferences and started talking about this stuff. I'm like, wow, this is kind of cool. Really, like, my mother is a retired high school teacher, so I'm sure despite my best efforts, I absorbed some of that stuff from her, the desire to teach people and help people with that stuff. So writing books and giving conference talks and speaking at user groups just seemed like a very natural extension. Believe it or not, there was a time where I could not have even stood up in front of a group this small to give a talk. It would have made me nervous beyond belief. When I went to college the second time, I went to Sheridan College twice. I liked it so much. When I went the second time and did computer science, one of the courses we had to do was a mandatory presentations course. And I used to be one of those people up in front of the class, the paper shaking and that whole thing. I don't know what that dude taught me. It turned out later on that his wife worked with my mother. I found out afterwards. She was a teacher as well. Whatever that guy did aligned all the bits correctly in my head that I could give presentations to groups from this small to like talking to like 2,000 people, no stress. It's all the same to me now, doing these presentations. And it always amazes me that I'm able to do this, and it always amazes my kids that they're like, how many people were at that thing you're talking about? And they're like, oh, I can never do that. I'm like, well, maybe one day you'll figure it out like I did. So I started to really like learn about testing, not just like about the tools, but about why. Why do we do this? Are there, for those who are familiar with design patterns, right? Like front controller and repositories and all that sort of like higher level stuff that you start migrating to. You start off just as like a coder, and you're just writing PHP code or code in whatever language, and you're cutting and pasting examples and you're figuring stuff out. Then you're like, okay, now I want to start to learn about like, okay, I start realizing my code looks like garbage and it could be better. So what are some techniques? And then you find out about like design patterns, and you find out, well, oh, that's cool. There's this model view controller thing that most frameworks use. And within that too, there's the front controller pattern where all our requests go through the front thing. And then we want to start doing database stuff like, oh, cool. I can build this thing called a data mapper where I'm going to talk to the database. So all those things. So I started wanting to find out, are there patterns for testing? Well, the answer sadly is sort of. Not formalized in the same way, but there were lots of people doing that sort of stuff. But of course, they were invisible in the early 2000s because so much of it was academic and so much of it was in languages that I wasn't working with. I was a PHP person for a super long time, 1998 until I guess when I started working for Mozilla like almost 2 years ago, right? So it's a long, long time of doing PHP. So what did I discover though? Because I learned this myself. People struggle to learn about testing without help. It's a people thing. This has nothing to do with the tools. The tools themselves, despite what some people think, are actually quite easy to use. The concepts are simple. We're writing tiny bits of code, ideally tiny bits of code, to prove something, to make an assertion, to say that I believe this code I'm testing should behave in a specific way. And then we write a test to prove it. And if the test passes, great, then the assumption was great. If the test fails, then you're like, okay, let's go look at this code and then figure out what we need to do to change the code to make this assertion work. So again, the difference is between now and then is back then, again, there was nobody in the PHP community doing this. For years, I'm not exaggerating, for a good 5 years, I was the only person talking about testing at PHP conferences. I went all over the place and was the only one doing it. Now, thankfully, lots and lots of people talk about it. So I feel like of all the stuff I've done in my career, that's the thing that I'm most proud of, that I no longer have to be the only person talking about testing, right? But people struggle to learn this without help. And why? There's a couple reasons why this is so hard to learn on your own. The internet is full of examples of things, and most of them are garbage. There's a few good ones out there, but this is the problem. The examples that we see for teaching people in a self-taught environment, they're way too simple, right? And at the same time, we also have people who are looking for shortcuts. Like, okay, well, we're bosses, we have to test. So they want to try to find like the path with the least amount of friction. Like, oh, you can get some tests so they can leave me alone so I can get back to reading Hacker News or get back to whatever it is they want to do other than the job that they're actually doing, right? And then again, this is a theme, right? Repeating theme about people. People want to argue about tools and techniques rather than just shutting the fuck up and getting down to writing some tests, right? So what's going on here? Like, TDD isn't simple because testing isn't simple. Now, the tools are simple, but again, there's this thing where simple things can display complex behavior, while complex things can only display simple behavior. A good analogy for this is a number of years ago, some people created some virtual birds, and they gave them a bunch of simple rules to say, okay, we're going to create a bunch of birds and then put them into an environment and get them to fly. And as far as flying goes, we give them a bunch of rules. Don't get any closer than X distance from the other bird. When you see a bird move, if more than one bird is moving in that direction because of an obstacle, follow that bird. So it's like 3 or 4 simple rules. Then they unleash them into a virtual environment, and they said, okay, let's see what they do. And with those like 3 or 4 simple rules, they found that these virtual birds behave like you could see real birds behaving in the wild in terms of flying around obstacles and flocking behavior and stuff like that. So when I say that testing isn't simple, it's true. The tools are simple, again, despite what people might want to lead you to believe. The concepts are the same. The tools are wrapping code. We're writing code using a framework. The framework has a bunch of ways for us to prove that scenarios are true through assertions, for the most part. And then there's a whole bunch of helper stuff wrapped around to try to make it convenience methods for this thing, right? If you look at something like PHP unit, my experience has been, that's the tool that I use most often. I'm branching out into other things on the PHP side because I'm starting to work on some stuff to teach people how to get better at testing legacy code base. And there's better tools in PHP unit to accomplish that. But you know, for PHP unit itself, there's 3 assertions that you need to use, and everything else is pretty much a wrapper around that. You're going to assert something is true, assert something is false, and assert something is equals to each other. Expressions, right? That's it. Everything else is kind of like just a wrapper around one of those 3, right? So the concepts, the tools are simple, the concepts are, but testing itself isn't simple, right? Because there's all this other stuff you have to know. It's not enough for me to say, just go install PHP unit, and then you can write tests. Of course not. There's all this other shit that you need to know, right? And also the big thing too is that because your code isn't simple, right? There's lots of nearly untestable code out there. That's the way that is that way just because the people who wrote it weren't thinking about making this thing testable with the tools that they know. They're just like, well, I just wrote this thing and I tested in my browser, you know, F5 driven development, just refresh. Okay, looks good, right? But people's code isn't simple. So there's always this thing where, okay, well, sure, maybe you can get PHP unit installed, and you can figure out how to, on your own, how to create your first test class, and maybe you can figure out, oh, there's this setup and teardown method. Maybe you can figure out how we can annotate tests, or that they need, or that the method needs to be named test. Maybe if you get to that, you can get through all that on your own. Maybe. I mean, I did, but I'm certainly, maybe special is not the right word, but just way more driven, and there was a lot less information, so I kind of had to dig into all this stuff. Nowadays, it's just easier to blow it off and go do something else. But the code isn't simple. So it's not enough for me to say, well, here's some, like, you know, a couple easy rules. Do this and don't use hard-coded dependencies, but like it just doesn't reflect reality, right? There is difficult code, and everyone's code is different. So it's very hard to take like an example that you find on a web page or go on Stack Overflow. How do I, you know, well, I have this loop, and how do I test the loop? It's like, well, okay, that's such a generic question. The answer is always, it depends, which drives most computer programmers nuts, because most computer programmers are quite logical, and they want everything to be black and white. Easy, yes, no, easy peasy, lemon squeezy, just so, you know, we figure it all out, so they can, again, because they may have other things they want to do. I mean, I work with some people in Mozilla who are like super logical to the point where, like, I'm thinking to myself, I'm glad I work remotely and I'm not in the office with you, because I would like be screaming, like laying my hands on you, saying, stop that nonsense, right? Code isn't simple, right? Because people aren't simple. And I think it's way more important to teach people about tools and techniques than to just spoon feed them an example. Because tests are like, I know it's a funny phrase, tests are artisanal. They have to be crafted for your code. I just can't take someone else's tests and apply them to your code. Some people have asked me if they could do that. Are test suite transferable? And since I'm the type of person that always believes there's no such thing as dumb questions, there's just like really bad answers, I didn't want to say that's a dumb fucking question. Instead, I wanted to say, well, tests are kind of purpose written for specific code, so you can't really take a test suite and move it over. It doesn't, the language doesn't let you do that, the tools don't let you do that. I can't even imagine what a test system would look like that you could just move a test suite and apply it to someone else's code. On the PHP side, I know you were going to say something?
I was going to say, I can't imagine the domain would be that similar.
Yeah, that's always the thing too, right? But I think it's way more important to teach, so I've shifted to teaching people about tools and techniques, because much like programming skill, they're transferable to other languages and other problems. Even within, you can go from one PHP project to another, and if you know how to use the testing tools, then you can probably figure out how to write tests. If you go to another language, if you go to a similar one, a scripting language, you know, one of what I call the dynamic algol family, one of you have PHP, you have Perl, There are still people who do some really cool Perl stuff. You have Python, you have Ruby, you have JavaScript. If you learn how to kind of use the unit testing tools for one of those languages, they're transferable. Other ones. Java is a little bit different. Statically typed languages and compiled languages are a little bit different because there's a whole category of bugs that you don't have to write tests for if you're compiling things, because runtime stuff, it'll figure out any kind of weird runtime errors, usually, if you're compiling something. Not to say that there are bugs, but I'm just saying, when you go from a dynamic language that's being evaluated at runtime, it's very different from a compiled one. So I teach people techniques so they can then turn around and apply them to their own code. Because it's not enough for me just to teach people how to do stuff. Like, you need to understand, okay, I've given you like kind of a meta framework to apply to the idea of testing. So we have the code, and then we have a framework with which that contains tools that we can use to test our code, but then we need a meta framework around all that, which is our understanding about how we take these tools and look at our code and apply the correct tools and techniques to get the testing results that we want. Again, it was kind of like a boop moment where I kind of look at it from just a slightly different perspective after being frustrated about, I've been teaching all these people how to use PHP unit and when to use the different types of doubles and using helpers and data providers. And like, why are people still like having such a hard time? And it's like, yeah, because you're looking at it wrong. You're assuming they're thinking like you, and that's a very natural thing for people to do, to assume that everyone else is like them. And that's when we get into this really weird zone where people become the problem instead of the tools, right? So, I mean, you might snort at, yet another example of using FizzBuzz. I know, does everybody here know what FizzBuzz is? Yeah, it's a typical interview question. It's the idea that it's typically used as an interview question where you have an algorithm where you give people a collection of integers, and you want to iterate through those integers, and you want to return back that same list. But if you come across anything that's divisible by 3, you want to swap it out for the word fizz. Anything divisible by 5, swap it out with the word buzz, and anything that's divisible by 3 and 5, FizzBuzz together. So it's commonly used as an interview question. I actually like doing it for tests because it forces people to use most of the common programming techniques. You need to know about loops and arrays and how to do conditional statements to check for things. But for a testing perspective, it's great because it's always a known answer. I can take any set of positive integers and very quickly tell you it should be 1, 2, fizz, 4, buzz, whatever, right? It's easy to generate the solution, right? So some people may go, oh, this is so stupid. But if you're not paying attention to the process by which I show, here's a problem. We're going to use TDE to solve this problem. Here's how we want this thing to look. Let's all write this code up, assuming everything works perfectly. So we have our test, and then we go back and write code until the test passes. That's the process that's important. People get hung up on the FizzBuzz. Still, even still today, when I do workshops, people get hung up on, oh, this FizzBuzz thing is so stupid. And I'm like, well, there's a reason why I'm up here teaching and you're there in the workshop, right? It's because I understand FizzBuzz is just a delivery mechanism for teaching you how to test stuff. Because this is, again, testing, it's a people thing. It can't be learned in isolation. It's best learned, of course, from someone that has done it before, right? It's best if you're in a development environment where you have mentors, where you have senior people who aren't assholes and who are willing to share things with people and teach you and set aside time. It also requires management to understand we need our senior people to train our intermediates and juniors so that everyone levels up instead of people getting frustrated and self-sabotaging projects or leaving the company in a lurch by just quitting. I mean, loyalty is a two-way street. Employers love it when you're loyal and work 70 hours a week and you're enticed by foosball tables and free lunches and all that other shit that's just a trap to get you to keep working for somebody else above and beyond what you should be giving to them, right? Can you tell them like a work-life balance person, right? But you can't learn about testing in isolation. You can't learn to test on your own. It's just, there's too much. There's too much stuff that you need to learn. And you need to actually watch someone who knows what they are doing guide you through the process and say, to talk things through. Okay, we're going to design this thing, and now we have this. Now, oh, this is interesting. This is failing. Or we're using the real thing. Now we're going to move on to creating a double. And why are we creating a double for this thing? Well, we're creating a double for this thing because we don't want to have to maintain a database just for testing purposes. Or we're doing this API call, and we're rate limited. We only have so many calls a day that the API provider allows us to make. So it's like all these little things that you cannot possibly learn on your own. maybe there's a couple savants out there who can like teach themselves all this stuff. I learned it. It took me probably took me a good 6-7 years of like pounding my head against the desk and asking anyone I could get a hold of online via email and mailing lists and asking questions in news groups to figure out how to do all this stuff, right? I'm just trying to shortcut this for people now to show them like, look, it's like I suffered so you didn't have to type thing. I want people to be testing their stuff, for it to be very natural, to understand we can do this. The tools aren't difficult. I can teach you the concepts. It's repeatable. It's transferable. It will save you time. It will save your company money. Only the dumbest of managers don't understand that when you say, it'll cost me $10 to fix the bug here or $1,000 to fix the bug over there in terms of resources. Only the stupidest person is going to say, I'd rather you spend the $1,000, right? Because testing is code written for a specific purpose, right? The test is a code to prove that something is working the way that you expect, whether it's an assertion or you're checking if an exception is being triggered, or if you're looking was an event triggered, if you have an event-driven architecture. It's code that's written for a specific purpose. It's not generic stuff. It's not transferable. It's all custom crafted code to prove that a scenario works. So after learning all this stuff, I've started really changing what I teach. I used to focus on the tools. Here's the tools. Here's why I use them. Aren't test doubles are awesome. Look, we can use this thing mockery to create doubles. Oh no, there's this other thing prophecy. And you got kind of like, I got caught up in the new and shiny part of testing, obsessing about the tools when I should have been obsessing about the process and about how do I take. I sat down and said, okay, especially when I wrote some of my books, I was like, okay, I'm going to sit down and like write down everything that I need to know to write this test. And I was just flabbergasted about how much stuff you needed to know before you wrote a single line in your test. So that's the thing I'm trying to teach people now. How do we learn all this stuff? How do I guide you through understanding running a test? But there's all this other stuff that you need to know before you can even start testing. And that's what makes the testing so difficult for people to learn on your own. It's not enough to have an example you can cut and paste and put in, because you don't understand it. You're still going to go, okay, it works, great, I have a test, but you need to understand why. What is it I'm doing? What is the framework expecting me to do? Why am I using this assertion as opposed to this other assertion? Why did we use a double? Why did we use a mock? Why aren't I using the real thing? Doesn't matter. We start getting arguments about what do we call this test? We have units, integration, functional, all that stuff. Is like I'm trying to cut through all that stuff and like make people understand, yeah, there's all the stuff that you need to know. And just have it so that you learn what you need to know and you learn to filter out the rest. Because, like I said, it's no longer enough just to show people how to use the tools. You have to show them the where, the when, and the why to use them. That's not the topic of this talk, but this is the thing that's important to me today, these days. Where your tests go. When are you testing? When should you be writing tests? And why? Why are we doing this? Other than just, for me to like to hear the sound of my voice, or you want to learn something like why are we doing this testing thing? It is kind of an existential question. But part of the problem when we talk about people is that people are desperately seeking shortcuts, right? This is what I used to hear all the time when I worked for that dating site from a few of our developers who resented having to write tests. I would be finished with this task if I didn't have to write the test and be like, you're doing it backwards. We write the test assuming everything's working the way that this bit of code is supposed to work, and then you fix the code until the test passes. But too many people do, even today, they do the same thing. They write the code, and then they go back and write the test afterwards. And it's like, you're missing out on the ability to use the test to design this thing. Code that was written using test-driven development looks very, very different than code where tests were added on afterwards. It just looks different because code that is written with testing in mind, it starts to always have the same type of shape. We have a large number of objects with a very small number of methods inside each object, and they all interact with each other. And it's very clear what dependencies are being used, and it's very clear where do I get this dependency from, and where does this other dependency go? The code all looks the same. It's almost, how many people have ever heard of hexagonal architectures or ports and adapters? Okay, so for those who don't know, it's kind of like you're talking about message flow, and you're trying to control through ports and adapters where things go. For your typical web application, you want to have your request comes in at one point and then gets dispatched, and everything only ever flows one way until you get into you're deep into the business logic where now that I've had everything, and it might get transformed along the way. We read it, we strip things out, and we grab from our post variables, and we just do a bunch of things. Then it gets to where it needs to be, and then the decision is made. Okay, now we ship this thing back out the other way, and maybe it goes out to be displayed as HTML, or maybe it goes out to be displayed as JSON, or it's packaged up and shoveled into a queue somewhere for processing. But it's an idea of controlling things. We're passaging messages. We're just like, it comes in, we're passing this little package from method to method, from object to object, transforming it, doing something, and then out it goes the other way, right? When you start using TDD, your code starts to look like that because you're writing these methods that accept parameters and accept dependencies. And they become small because you start focusing on, well, I just need it to, you start realizing, well, I only need this object to do this one thing. So you stop having what people refer to as the God object, where you have one object with like 100 methods on it. It becomes very, very clear when you need to do something where that work needs to be done. And because you have all these tests that show how the code is using, it's usually really, really easy to extend a code base that has lots and lots of tests. Because you have all these examples. You can quickly drill down to, here's the specific object and method that I need to modify to accomplish this task. And then you have all these tests to make sure you didn't accidentally break something somewhere else, right? It's about confidence in deployment, right? I've written this code, we have really good code coverage, I'm 100% confident we can deploy. I want deployments to be trivial for you. I worked at places where everyone had to stick around when a deployment happened. Why? Because there were no tests, right? It happened, it's a thing. But like now at Mozilla, there's some projects where they're deploying multiple times a day. But they can only do that because they made this commitment a long, long time ago to say, we're gonna have tests, we're gonna run everything through, we're gonna have a really good peer review system, we're gonna have a system that can run lots and lots of tests in a short period of time, and that way it becomes trivial. You want your deployments to be trivial. You know, there's this thing, never deploy on a Friday. Well, why? Because you might ruin someone's weekend, and they're gonna be late, they're late on a Friday. I don't want people ever to work late. I want you all to go home. I want you to do what I do, which is go, well, I mean, I work from home, so technically I'm at home already, but be done work on time. And never feel like, yeah, the computer's over there, I just need to do one more thing, or I need to stay longer. So, no. 5 o'clock comes, and unless there's like something that I fucked up early in the day that I need to fix, at 5 o'clock I'm done, and no more work for the day, right? But I got this all the time. People looking for shortcuts. They look at the testing like, oh, maybe this thing's gonna save me. Maybe, isn't there some way I can like automatically write tests? Like, no, of course not. No one's gonna automatically write a test for you. It's just nonsense. It's wish casting. There are no shortcuts, none. So there are no shortcuts. There's just lots and lots of work to try and create things with the fewest bugs possible. People write code. People make mistakes. In fact, I'm pretty sure that all of us here, we probably make the same mistakes over and over as we write code. We have our own blind spots. We have things that we're strong at using. We have things that we're weak at using. My code, I tend to make the same mistakes all the time. It's like, fuck, I did that again. Why did I do that, right? And then I'm like, oh, I know why, because I decided not to write a test. So I'm gonna do the test this time. And it catches the mistake before I make it. But it's, you know, software is not easy. The amount of tools that get thrust upon us to accomplish what used to be pretty simple, there's more and more of them, right? Especially if you do web work, it's not enough just to know a little bit of HTML and some CSS, and then you could do a server-side language like PHP. Now it's like you gotta know some JavaScript, and you better know about something about Gulp or Webpack or whatever one they came up with yesterday that will be obsolete tomorrow. Right? We have to bundle our assets up, and we have to trick the browser into caching them for us. So there's so many things you need to know. Of course, shit keeps breaking. This is why the web is just full of garbage, right? 99.999% of the web is garbage because there's just too much people need to know, and nobody wants to do anything simple. There's this appeal to ego, and people want to use the new and shiny and prove that they know what they're doing. I mean, I've been in this industry 20 years now, and I got over that whole thing about wanting to impress people a super long time ago. I started preferring to make money to impressing people, and people can be impressed with what I've done. And, you know, I just tell people, look, man, I've done all these things, and I made a commitment to testing, and look what it's got me. I got a nice car with a customized license plate about testing. I live in a beautiful house in the middle of the country. I work from home. I work 1/10 as hard as a lot of my peers, and yet I make just as much as them. So you tell me who's been making the wrong decisions and being stubborn about stuff, right? Software is hard, but there's ways to make it not so hard, and testing is part of it, to give you confidence that you can deploy things and push things and know that you're going to change something. You have broken stuff, because people are always the issue. So I started writing books and giving lots of talks and doing this stuff. And what I found out too is there's 5 lessons. Lesson number 4 is that all these testing problems and techniques, like so much stuff in computer science, were solved in the 1970s, which is like really depressing when you like look at something and you feel like you have an epiphany how to do something, and then you're like, no, like some professor at some small college in the US wrote a white paper about it in 1973. That just shows you how stupid you actually still are about the topic. It's all invented. If you are serious about wanting to get into testing, and I know it's not for everybody, because it was a lonely path for many years, but this is the book to buy. It's not in print anymore. Boris Beiser's Software Testing Techniques. A friend of mine who I follow on Twitter, who's a really interesting guy. He's a software developer from Uruguay who had an Italian grandparent, so he's able to get an EU passport, and he works for a company in Switzerland. And I used to think I read a lot of books about stuff. His name is Alvaro. He has read so much ridiculous stuff. He also reads white papers and stuff. And he, a number of years ago, just said, Chris, you're into testing, right? Because I spoke to him on Twitter. And he's like, you're into testing. I'm like, yeah. He said, go buy a copy of this book. So I think you will find a lot of things that you are currently struggling with are answered in there. And it's true. This book here outlines for you all these, I talked about design patterns before, like, model view controller and all that stuff. This is the design pattern book for testing. If you get your hands on this book, pretty much every type of test that you're going to need to do is covered in this book. Now, it doesn't cover, like, if you look at what Kent Beck and the other folks that worked on NUnit did, they took a lot of the ideas that are expressed in this book, and I don't necessarily think they used this book as inspiration, but a lot of the concepts they then applied to create a framework for applying some of these things. Every scenario I've thought of, or system I've come across, if you can get it to a high enough level of abstraction to figure out what this thing is doing, there's an answer in this book about how to test it, about random things, how you test stuff when the resources are only intermittently available, like how you do like some of the really like weird edge case things that you're trying to figure out when you have a sufficiently complex system. They're answered in this book. So if you're interested in like really digging into software testing, and again, like you can do it, it can be rewarding, but it's a long slog. Because again, it's like so much other things that we do are in the 70s and 80s, not just testing, but like computer science stuff. The one skill that I wish I had was how to read a white paper and convert the ideas expressed in that white paper into code. I am, for the most part, self-taught when it comes to computer stuff. I went to Sheridan College for computers, but this was I graduated in 1994, 96? Yeah, 96. Before the rise of the commercial internet. We didn't even get a graphical web browser to use at the school until like 2 months before we were finished. Surfed the web in text, did email in Pine. So the text internet was all I knew. So none of the stuff that we have now, Mosaic, which is like the precursor to Netscape Navigator, they had it at the lab, but so few people had access to it. But everything, like all these techniques and computer science stuff that people are struggling to figure out today, 1970s and 80s, people invented it, but the problem is so much of this research is just kind of obscure and hidden behind paywalls, and you have to really, really dig around to try to find this stuff. So we're doomed to continue to reinvent stuff that a bunch of old white dudes with long beards figured out in the 70s and 80s, right? But the big thing too is programmer hubris, right? Leads so many people to think that they were the first people to figure stuff out. And again, this is just like, it's the level of arrogance amongst computer programmers is ridiculously high. Even people who don't think they're like that. I know I get that way sometimes about stuff. But the idea that you're the first one to figure it out, or you can figure it out without help, or refusing to look and say, the idea that you never say to yourself, has someone else solved this problem already? Because me personally, I prefer to use other people's solutions to problems. So I can save my brain power for for more important stuff like magic cards and what am I having for lunch, and do I have to upgrade my testing tools? I'm more than willing to take someone else's work and build on it and use it. A lot of people aren't. A lot of people want that ego boost of having created something. So that's why we see things continually reinvented instead of built upon, right? Yeah, sometimes there's like evolutionary, quote unquote, leap forwards in technology, but most of the time it's a slow, steady progression, and you get the most results. Like innovation can sometimes happen by just taking something that exists and just making that thing better, rather than creating something that sort of looks like it but completely new that you control, right? Like innovation can happen on old things. And this is the thing, like more programmers need to like do things like go back and look at computer science books from the 70s and 80s, because you'll find solutions to your problems in there. All the stuff that we're talking about, distributed applications, cloud services, all like people figured this shit out like 40 years ago. But we'd like to pretend, oh, we're the leader, and when you thought of this, like, no, buddy, you didn't think of this. Someone else already did. You're just not aware that they had thought of it. Because this is the whole thing. This is the internet in a nutshell. Cartoon cat and a cartoon mouse, ready to shoot each other's brains out over trivia, over what asset compiler pipeline tool I should use. When do I use integration tests? And when it's like, holy fuck, people. Like, these were decided 40 years ago. Ignore it at your own peril. Because the fifth lesson, problem is people, right? Because testing your code requires you to change how you write your code. This is the lesson that was drilled into me very, very early on. And to be perfectly honest, people don't like it. People don't like being told that what they're doing is wrong in this context, and you need to change it. Because despite most people prepare themselves, oh, I'm open to change. I love using new tools. No. You like using new tools. They like to change what they use, but not how they use it, right? People love to use new operating systems, love to use shiny new laptops. I'm not immune to that. Love to use new JavaScript frameworks and love to learn about functional programs. But you're still solving your problems in the same shitty way you're doing it before. You need to change some fundamentals about how you're approaching solving problems. People love to change what they use. They love to switch between editors. They love to switch between frameworks. People go from this framework to this other framework. How can you not use this framework? People build whole conferences around frameworks, but no one is usually willing to change how they're using the tools that they have already. Testing forces you to change how you write your code. You find very quickly, I can't keep doing foo equals new something inside my methods. That's a dependency that's hard-coded, and I can't control that in my test. So you learn very quickly, I need to use dependency injection to set all my dependencies so I can control them at runtime, which means I can override them when I'm doing a test. Sounds trivial, but that is actually a fundamental change in the way that some people write their code. And some people never get it. And some people get like really defensive about it. What do you mean I gotta change how I'm doing this code? Why can't the test figure it out? I'm like, because the test can't. The tests don't figure out intent. The test is proving something that already exists, happens in a specific way. Because to me, it's always funny how the quest for new and shiny never seems to include tools to help make these new shiny things bug-free. People get bored, right? Programmer boredom. It's like, man, you don't realize how privileged you are. You get to do this job, and people throw tons of money at you, and you get lots of people like literally worshiping what you do because they have no clue about what it's really like. And so you get caught up in, I want to do this new thing, but it's like the next thing. I worry about falling behind, whatever. FOMO, fear of missing out, all this stuff. Like, your job should be to solve problems with the fewest mistakes possible. And I wish more people looked at it that way. People are always like, check out this new thing I did, check out this new thing I did, check out this new thing. No one's ever like, hey, look at this cool problem I solved. Look how my code doesn't have bugs anymore. No one, never see that. Because people their ego gets in the way. They're like, oh, my code's perfect. What do I need tests for? Or this project is so small. What do I need tests for? It's like, yeah, well, I can tell you as both a programmer and as a parent, habits that you see when you're really young in somebody, they're probably still there when they're older. So I think early in your programming career, if someone doesn't show you how to change those habits to get better outcomes, you're just going to keep doing the same bad habits. And then most likely you're not going to blame yourself. You're going to blame your tools. You're going to blame the problems you're being asked to solve, and you're going to blame your coworkers. Whereas the real thing is the problem is looking back at you in the mirror. Requires fundamental changes in how you do things. So, shameless plugs at the end, because I got told I shouldn't talk about myself at the beginning. So my name is Chris Hartjes. I currently work for Mozilla, the Firefox people, and public service announcement. I don't care whether you use Firefox or not. I prefer that you use it, but money shows up in my bank account twice a month whether you use Firefox or not. So I work for Firefox Test Engineering. I test services. So all the things that Firefox talks to behind the scenes to synchronize your bookmarks across devices, to tell you when there's new updates, to tell you that you need to install the latest extension. The team I work on tests all those things. So I spend my days working closely with developers, which is nice because they respect me because I used to be a developer. Okay, sure, whatever. I use PyTest all day long to write tests and create automated solutions so that every time a new service gets pushed, there's no bugs, there's no catastrophic failures, and everyone goes home on time. You can find me most of the time on Twitter doing performance art as Grumpy Programmer without the U. If you visit grumpy-learning.com, you'll find a couple of things there. I have a whole bunch of books there. And this is the part where I shill right at the end. As I mentioned at the beginning, I used to run True North PHP, which is I know some of you went to it. For those watching the video who don't know, small little PHP conference, about 120 to 130 attendees. I'm running my own event in the spring. It's a combination professional development conference and a birthday party for me. It's from March 22nd to March 24th out in beautiful Ingersoll, Ontario, where the Elmhurst Inn and Spa is. Check out the website for more details. I would love to see a bunch of people there. I have 6 really awesome speakers who I all know personally, who are really high impact, and I think it's an opportunity to do something really unique and get a chance to talk to people who know what they're doing in the realm of software development with PHP and help you really up your skills as both technically and the people skills that you clearly need to survive as a programmer. So that's all I have. Oh yes, also, and this is my friend Ed, it's from another thing, but I also do a podcast with my friend Ed Finkler called Development Hell. It's been a while since we did it, but 93 times we've gotten together to talk about whatever we wanted to talk about programming. So anyway, thanks so much for your attention.